All right, here's example number 2 from 6.4. I wanted to make a new video with this example because these examples get a little harder than example number 1. We're still adding and subtracting, and we're still adding and subtracting rational expressions. So let's continue to follow those steps where we factor so we can find our common denominator. Once we get a common denominator, we can combine these fractions by keeping that common denominator and adding or subtracting the numerators together. But I want you to look at A with me. It looks a little bit different than example number 1. On A, none of my denominators are factored. So what we have to do first before we can figure out what our common denominator is we've got to factor each of these denominators. If you look at the first denominator, that looks like it's a factored polynomial that's a difference of squares. If you look at the second polynomial, that looks like it can be, I can factor out an A, right? A GCF. So let's factor out both of those denominators. So my first fraction is a 2a over an a minus 1 times an a plus 1. And my second fraction is a 1 over, and when I take out the a, I have left an a plus 1. All right, I want you to look carefully at the denominators. And if we're trying to add or subtract, remember we need to have common factors, a common denominator. So I need to make sure that both denominators have the same factors, the same stuff. If you look at the first fraction, I have an a minus 1 and an a plus 1. But what is it missing that the other fraction has? Isn't it missing that a? So I'm going to multiply the bottom by an a as long as I make sure I multiply the top by a so I keep my fraction balanced. Let's go ahead and look at the second fraction now. My second fraction has an a, it has an a plus 1, but what other factor is it missing that the first fraction has? It looks like it's missing an a minus 1. I'm going to make sure I put it to the bottom and the top to keep my fraction balanced. All right, now if you look at my denominators, they both have a's, they both have a minus 1s, and they both have a plus 1s. So now they're a common factor. They have all the same stuff. They have a common denominator. Since that's the case now, I should be able to combine my fractions by keeping that common denominator and just adding the numerators together. In my first fraction, 2a times a is 2a squared. I'm going to take this positive 1 and distribute it through. So I have a 1a minus 1. So this is what I have so far, but let's see if we can reduce it even more. I want you to look at this numerator. It looks like that's a bottoms-up factoring. Can we bottoms-up factor that into smaller factors and see if there's a common factor between my top and bottom, my numerator and denominator? Because if there is, we can simplify or reduce this answer a little bit more. When I did bottoms up, I ended up factoring the numerator into an a plus 1 and a 2a minus 1. My common denominator, remember, was the a minus 1, and the a plus 1. But now look what happens. Don't I have a common factor on the top and the bottom? So I can cancel out the a plus 1 on top and bottom. Now be careful. The 2a minus 1 looks close to the a minus 1, but it's not exactly the same thing, so I can't cancel those. So it looks like there's still a 2a minus 1 left at the top, and an a times an a minus 1 on the bottom. No other common factor, so it looks like that would be my final answer. All right, let's do the same thing with B. Let's factor if we can to get a common denominator. Once we have a common denominator, let's combine our fractions, and then let's see if we can simplify more. You ready? All right. Looking at this one, it looks like my bottom is already factored, and x minus 2 is as small as I can get, right? As factored as I can get. I also have an x plus 5. Now, I don't know about you, but I notice that all of these binomials are connected with a plus or minus sign, and it always makes me feel more comfortable to put parentheses so I know that they're connected. I'm subtracting these two rational expressions, so I need to make sure that I get a common denominator. All right, the first fraction has an x minus 2, but what factor is it missing that the second fraction has? Well, it looks like it's missing that x plus 5. So I'm going to multiply both the top and the bottom by that factor. What is the second fraction missing that the first fraction has? It looks like it needs an x minus 2. Let's multiply both the numerator and the denominator by an x minus 2 to keep it balanced. And now I have common denominators. Now that I have common denominators, I should be able to combine those fractions into the same common denominator. You see what I did there? I just put a CD as common denominator, and my numerator is the x plus 5 times the x plus 4 minus the x minus 7 times an x minus 2. And then I put CD, common denominator, there for a second. I'll show you why. What we need to do is we need to make sure that we combine our like terms in the numerator. What I mean by that is we need to make sure that we FOIL this, that we FOIL these two binomials, and we make sure that we distribute the negative through. So that's what we need to do first. I'm going to FOIL the first one. I'm going to FOIL the second one. And then you notice there's a subtraction sign that needs to be distributed to every single term in the second parentheses. So be careful. Once I do that, I can combine like terms. You should have a positive x squared and a negative x squared. You should be able to combine all of your x terms, and you should be able to combine your 20 and your negative 14. I ended up getting on the top an 18x plus 6 over that common denominator, remember, of an x plus 5 minus x minus 2. Now, if I can reduce more, then that's what we need to do. So let's look again really carefully at our numerator to see if we can factor anything out. It looks like I can factor out a GCF of a 6. If I take out a 6, I would have left a 3x plus 1. But it doesn't look like there's any common factor between the top and the bottom, so it looks like that would be my final answer. Either of these would be acceptable, since I can't reduce it any farther. All right, you notice that I put that CD on as my common denominator, because if I write my common denominator, you can. You just have to be careful that I often see students trying to reduce these or reduce these, and you cannot. Remember, if you reduce, you have to be able to reduce all parts by that factor, or it's not a common factor. So since this one has an x plus 5 and this one has an x plus 5, but this term does not, we cannot reduce by the x plus 5. Same thing with the x minus 2. Since they all three don't have an x minus 2, I can't divide an x minus 2 out of my terms. So it's helpful for me to, instead of writing that denominator, is write a CD for common denominator. That way I don't forget to write it later in my answer, because it is part of my answer, but I don't accidentally reduce it when I'm not supposed to. Just a trick that kind of helps me. You can use it if you'd like. All right, let's do one more in this video, practicing adding and subtracting rational expressions. If you look at C with me, we're subtracting these two rational expressions. So we know as soon as we see adding and subtracting of fractions that we need a common denominator. Let's go ahead and factor those denominators so we can figure out what their common factors are. It looks like both of these are trinomials that can be factored using basic factoring techniques. Why don't you go ahead and factor both of those denominators, and let's see if you get the same factors as I do. All right, the first one factors into an x plus 2 and an x plus 3. The second denominator factors into an x plus 2 and an x plus 1. Now, if I need a common denominator, we need to figure out what factors the first fraction needs that the second one has. It looks like it has an x plus 2, but it's missing that x plus 1. So I'm going to multiply the top and the bottom by an x plus 1. So it now has an x plus 2, an x plus 1, and an x plus 3. The second one has an x plus 2, an x plus 1, but it looks like it's missing the x plus 3 factor. So let's multiply that to the top and the bottom. All right, now that I have a common denominator, I should be able to smush these two fractions together with that common denominator. So my common denominator would be an x plus 1, x plus 2, and x plus 3. In my numerator, it looks like I need to make sure that I distribute this x through, and I really have a negative 2 right here that needs to be distributed to those parentheses. So this is what I have. I have an x times an x plus 1, and then a negative 2, because I was subtracting, right? A negative 2 times the x plus 3 over my common denominator. And again, you can use CD for a second if you need to. Making sure that you distribute the x and the negative 2 through, you should end up getting these four terms. And then it looks like you have some common like terms, the x and the negative 2x, that you can combine. So if I combine those, I end up getting an x squared minus 1x minus 6. Remember, over your common denominator, don't forget it, is an x plus 1, x plus 2, and x plus 3. Now, can we make this look a little bit nicer? Can we simplify or reduce this any more than it already is? Well, look at your numerator and see if you can factor it more. And maybe there's a common factor between my numerator and my denominator now. It looks like that's a basic factor problem. It looks like my numerator can actually factor into an x minus 3 times an x plus 2. And then look what happens. my x plus 2 from the top and my x plus 2 from the bottom reduce each other. And so then it looks like I have a final answer of x minus 3 over x plus 1 times x plus 3. Be careful not to reduce the x minus 3 and the x plus 3 because they're not the same exact factor. It looks like that would be my final answer. All right, make sure you practice those. We're going to get a little more complicated here in the next video. So make sure that you work through example number 2, A, B, and C, before moving on to the next one.